everybody, welcome to our section 4.8 video lecture on geometry applications of fractions, specifically looking at area and volume. So just a quick reminder of a couple things from previous chapters. Perimeter is the length around a figure. All you have to do to find your perimeter is just add your side lengths together. So it's the sum or adding sum of your side lengths. Alright, just a brief reminder. Area, that's the measurement of the interior, the inside of a figure. So the new figure, so previously we've done squares and rectangles. Today we're going to add triangles. The area of a triangle is 1/2 times the length of your base times the length of the height. And I have a couple of pictures showing you about bases and heights. For a nice little acute triangle like that, you can see your base here and your height there. The height should always be perpendicular to a base going through the other vertex, the other little corner point, okay? So this one has the height inside. This little obtuse triangle has the height outside, but you can see that height is perpendicular to the extension of that base. But that's what they look like in a couple different pictures, okay? So let's try a few. In example 1, it just says find the perimeter and the area of each triangle. So the first triangle I have has side lengths that are 26, 47, and 39 3/4 feet. Then it has a height of 22 feet, okay? So if I want to find perimeter, you add all of your side lengths together. So I'm going to have 47 plus 26 plus 39 3/4. So what I would do, honestly, is just add all of the whole parts together and then add the fractional parts together. So the whole parts, you have this 49, 26, and 39. If you add all of those whole parts together, you get 112. And then the fractional parts, you have one and you don't have one, and then we just have the 3/4 right here. So our answer would be 112 3/4. The units are in feet, because we have feet plus feet plus feet, which gives us feet. For area, you do 1/2 times base times height. So the height that I have is this 22 here, and one is perpendicular to the 47. So the 47 would be the base that goes with the 22. So the length of the base would be 47, the length of the height would be 22. I'm not going to use either of the other sides because the 22, that height, is not perpendicular to either of the other sides. It's only perpendicular to 47. So when I'm multiplying, the nice thing about multiplying is that you can do it in any order. So if it was me, I'd make my life easier and do 1/2 times 22 first. Half of 22 is 11. And then you can just do 47 times 11. Which is 517. For the area, for the units, you're doing 1/2 time, which has no units, times feet. And feet times feet would be square feet. So our units are square feet. We have 517 square feet for the area of that triangle. Let's do another one. In part B, I have this little right triangle down here. And I'm going to find the perimeter first, and then the area second. So for perimeter, add all my side lengths. I've got a 9-inch side, 11 1/10 inch side, and 6.5 inch side. So what I'll do for this is I'm going to add the whole parts together. So 9 plus 11 would be 20, and then 20 plus 6 would be 26. Then I'm going to add the fractional parts together. I have 1/10 plus 1/2. So that would be 1/10 plus 1/2, which is 5/10, which would be 6/10 when you add those together. You can simplify that a little bit by dividing by 2 in the numerator and the denominator to give us 3/5. So my answer is going to be 26 3/5. My units are inches because we have inches plus inches plus inches, which gives you inches. For the area, we're going to do 1/2 times base times height. So this one, since it's a triangle, our base and height actually end up being sides, which is kind of fun. If you notice that perpendicular mark right here, the 9" and the 6.5" are perpendicular to each other. So that means that 6.5 inches would be the height for the 9 inches. Or if you want to turn your triangle sideways, 9 inches would actually be the height for the 6.5 inch side. So we're going to multiply base, so 9 inches times height, which would be 6.5 inches. And let's see how that goes. So let's see, 1/2 times 9 would be 9/2. So 9/2. And we're going to multiply that by 6.5. I'm going to go ahead and make that into an improper fraction, so it's a little easier to do the multiplication. 2 times 6 is 12, plus 1 would be 13. So that would be 13/2 as an improper fraction. Okay? And if you multiply, it simplifies out. So we'll multiply straight across. 9 times 13 is 117. 2 times 2 would be 4. And since we started out with mixed numbers, we should be answering as a mixed number as well. So 4 goes into 17 29 times with a remainder of 1. So it'd be 29 1/4. For my units, I'm doing inches times inches, which would be square inches. So 29 1/4 inches squared for my area. And I just realized you can't see that. Here you go. Normally in a classroom setting, somebody would have raised their hand by now and said, "Miss Foster, I can't see it." I would say, "Thank you so much," and would have pushed my paper up. But we're doing this over video, so enjoy that now that it's up, okay? Let's see, in the next example, in example 2, it says, find the area of the shaded region. So the shaded region is this dark part up here. And what I notice for shapes is that I basically have a rectangle with a triangle kind of cut out of it. And so the shaded part would be the rectangle minus the triangle. It would be everything from the rectangle except for the triangle. So that's going to be my strategy here. For the shaded region, I'm going to do the rectangle area minus the triangles area. Okay? So let's do that. For the area of the rectangle, you just do length times width, so I'd have 30 times 40. Okay? Which would give me an area of 1200. Okay? For the triangles area, we're going to do 1/2 times base times height. So base times height. The height would be 32. It's perpendicular to this 30 centimeter side here. So my base would be 30 centimeters. My height would be 32 centimeters. And let's see, half of 30 would be 15. And 15 times 32 would be 480. So now if I just want the shaded region, I would do my rectangles area, which is 1200 square centimeters, minus my triangles area, which is 480 square centimeters. And so the area of the shaded region would be 720 centimeters squared. All right, the next thing we're going to look at is volume. So volume gets us into three-dimensional shapes, which is exciting. So volume is the measurement of the interior of a three-dimensional figure. Okay. And so I'm going to give you guys two different shapes. That's all we're going to work with today. We're going to have rectangular solids, which is a really fancy word for a box, and a pyramid, which you guys probably know what a pyramid is. Okay? So a rectangular solid looks like this. It looks like a box. Okay? And all you've got to do to find your volume is length times width times height. Okay, it's the 3 dimensions multiplied by each other. Okay, so L times W times H. A pyramid looks like this. It's doesn't have to have a square base. It actually could have different shapes as a base. You could have like a rectangle or all sorts of different stuff. You could have a triangle down there, but it always goes to a point from here. So the volume of a pyramid, just generically, is going to be 1/3 times the area of the base. And I say that because it's not always a square. You might have a triangle or rectangle or something else down there, but you find the area of the base. So this one would be a square base. It's the non-pointy side here. So you do 1/3 times the area of the base times the height. And that's how you find the volume of a pyramid. Okay? So we've got 2 examples down here, one of each shape. So first off, identify each figure. I'm just asking what shape do we have? And then we're going to find the volume. So for the first figure, what kind is it? This one is a rectangular solid. Okay, and if we want to find the volume, we just do length times width times height. So we'd have 2.5 inches times 7 inches times 10 inches. Okay. So let's see here. 2.5 would be the same thing as 5/2. So we're doing 5/2 times 7/1 times 10/1. We can simplify a little because 10 and 2 are both divisible by 2. So I can divide by 2 and divide by 2, which makes my life pretty easy because now I'm just dividing by 1. So it's actually going to work out pretty nicely. 5 times 7 is 35. And then 35 times 5 would be 175/1. So our answer for our volume is 175 cubic inches, because this time we did inches times inches times inches, which would be 3 inches multiplied by each other. All right, so our units would be cubic inches. All right, last one. Which shape do we have? It's a pyramid. So let's go ahead and find our volume. So our volume is 1/3 times the area of our base. So the base for this pyramid is a little rectangle, okay? So the area of my base, we would do length times width, which is to find the area of a rectangle. So we do 5 times 4, which would be 20 centimeters squared. So we do 1/3 times 20 centimeters squared, because that's the area of my base, times the height, which is 11 centimeters. And multiply all of that together. So if I were doing this, this would be 1/3 times 20/1 times 11/1. Nothing simplifies on this one. So I'll just multiply straight across. 1 times 20 times 11 would give us 220. 3 times 1 times 1 is 3. And I would assume that it would be a lot better to give this answer as a mixed number, since we're talking about something application-based or practical. So 3 goes into 220 73 times and has a remainder of 1. So it'd be 73 1/3. The units are centimeters cubed. So you're always going to have cubic units for volume, because to get the area we had square units. We did centimeters times centimeters, which would give us centimeters squared. Then we multiplied that by another centimeter, the 11 centimeters, to give us cubic centimeters as an answer. Okay, so hopefully this helps you guys out, and hope you guys have a wonderful week.